Hi everyone, and welcome back to this series of solving PEO exams, and this is a question about electrical A1 circuit exam. And in this question, basically, we'll be solving an AC analysis question, and this is the fourth group or fourth category of the questions that is presented in the exam. So basically, here you have an AC input instead of a DC voltage. So it is basically a sinusoidal voltage. And you will have inductors, capacitors, and resistors connected to it. But before going and solving the question, let's give some background about how we perform an AC analysis. So in AC analysis, basically, the circuit would be given to you either in time domain or basically in phasors. What's the difference between the two? That your Vs will be given to you as either a sine or a cosine function omega t plus minus theta, or the equivalent of this, the phasor, as an a and the angle plus minus theta. A is the magnitude and theta is the phase shift. So either you will have the voltage as this or as that representation. The resistance as an R, the same. The inductor as either L or J omega L. Omega is the frequency here. And the capacitor as either C or minus G over omega C. So you could have the circuit as such, all the elements, or as such. And I will try to have questions cover both areas. Now, if you are given, this is called time domain, and this is called phasors or frequency domain sometimes. Your first objective is to make sure that the circuit is represented in that domain. We will not solve the circuit in the time domain. Even if the output that is required to be in the time domain, we will solve it in the phasors and we will go back. So how to do that? Simply just move from the time domain to the phasors. Okay, so if you have your signal as a cosine omega t plus minus theta, have it as such. Now, this is a polar number, basically. This is basically a polar number with a magnitude and angle. Now, here you have to have a background on polar number and rectangular number. And just again, very, very fast, if this is the real and this is the imaginary of the number, okay? Now, if you have a number, let's say here that is as 3, as 4, so this is basically 3 plus j4. This is the real, and this is the imaginary. Okay, now basically what you do here, you try to find the magnitude and the angle. This is R, this is will be equal to the magnitude R and the angle theta. Okay, now the magnitude you applying Pythagorean theory, so this would be like 5, and the angle basically you will be, this is 4, so tan theta is equal to 4 over 3. Then from this you can find the angle. Now you don't need to do that manually in the exam. You can have a calculator that can do all these calculations. Now this is something very, very important that you have to deal with sometimes when you add numbers or subtract numbers. You better have them, or you should have them, in rectangular format. If you multiply or divide, it's better to have them basically in a polar format. And from the circuit perspective, there is not much difference between what we have learned so far in DC analysis and the AC analysis. They are all the same. The only difference in the math. In DC, we are dealing with scalars. Here, we are dealing with vectors. And these vectors, they are either in the polar format or in the rectangular format. So that is something that we will try to show to you as we progress. So with this is little a background. Let's now go to the question and try to see the question. Now this is my question here, and you are giving Vm as 100 volts. So the magnitude here, so this is 100 sine 2 pi if the frequency is 60 hertz. Okay, 2 pi, this is t basically here. This is in time domain as a sine function. Now L1 and L2 both are given to you as 4 millihenry, 4 millihenry. R1 and R2 both as 1 ohm, 1 ohm. And what you need to find is of t. So I want to find the time domain solution for the current is and the time domain solution for Vc of t, the voltage across the capacitor. And then there's something called the phasor diagram for vector Vs, Is, and Vc. So now when you look to this circuit, the circuit is basically given to you in time domain. We cannot solve it as such. We have to convert that into the frequency domain. Now, if I have one voltage supply only, could be in sine or cosine, I can use this as my reference. So the output will be in sine, okay? If the input is cosine, the output will be also cosine function. Now, if you have a circuit that has two supplies, and this happened often in the exam, one sine and one cosine, then you have to convert one to another, and we'll see that in future examples. So now let me convert the time domain to basically the phasor diagram, so that, or the phasor circuit representation, so that we can solve it. This is my supply, so I will take the magnitude, which is 100, and the phase shift here is 0. There is no phase shift. So that is my supply now. It's not anymore the sine function. It's basically the magnitude and the angle. Resistance, as I mentioned, nothing happened to it. Ohm. And then we will have here the parallel branch. Both of them are exactly the same. So we will have L is equal to 4 millihenry. This has to be converted to J omega L. And by the way, J is the root of minus 1. Okay, this is the imaginary number. So this is equal to J. Omega is 2 pi F, which is 60, times L, which is 4 times 10 to minus 3. This has to be in Henry, so this is approximately equal to 1.5 J, and the unit here is ohm. While L is in Henry, the J omega L, we call it the reactance, it is in ohms. So this is for L1 and L2. So we will have here basically J 1.5, J 1.5, and then the resistance, both of them is 1 ohm, 1 ohm. And then we will have here the capacitor. Now the capacitor, we are given C is equal to 10 times 10 to minus 6 farad. This will be equal to minus J over omega C minus J over 2 pi times 60 times 10 times 10 to minus 6. Everything has to be in farad or in Henry. And this will give me minus J 265.3 ohm. So minus J 265.3. So that is the first step. You will see some questions. You start from here. The circuit is already given to you in the phasor representation or in the frequency domain representation. So you don't need to do this conversion process. Now I need to find Is and I need to find Vc. Now we solve the circuit in that domain basically. And then after that, after we solve the circuit in that domain, we convert it. We go back to the frequency, to the time domain as we showed to you. Now, I can do some sort of circuit reduction here. I have an inductor 1.5 J, and I have a resistance 1 ohm. This is in parallel with another 1 ohm and J 1.5. Okay, when you look to this circuit, it is basically each branch is equal to 1 plus j 1.5. This is in parallel with 1 plus j 1.5. This is the real and this is the imaginary. Now, when you have two impedances in parallel or two resistors that they are equal, the resultant one will be half of that. So you will have this is equal to zero point 0.5 plus j 0.75. So let me now put the circuit, redraw the circuit. So this is my supply, and my supply is basically 100 angle of 0. This is my 10 ohm, and here I have a resistance and inductor. This is basically 0.5 and the J 0.75, and here I have the capacitor, and this capacitor is minus J to 65.3 ohms. So everything in ohms. Now I need to find IS. Okay, your IS, this is Ohm's law. Now here is the beauty of the frequency domain. You apply everything you have learned about the circuit. The only difference, as I mentioned now, you are not dealing with scalars, you are dealing with vectors. So this is IS, the current here is basically the voltage divided by the summation of all reactances, which we call it the total impedance. So this is 100 angle of 0 divided by, now all of them are in series, so 10 plus 0.5 plus j 0.75 minus j 265.3. So the real with the real and the imaginary with the imaginary. So this is 100 angle of 0 divided by 10.5 minus j 264.5. Now, when we do the division, we cannot do this division because this is in polar, and this is in rectangular. Now, there are certain calculator can do that directly. Okay, I will do it here in steps. So I will convert. When you do the division, I convert the everything to polar because, as I said, multiplication and division are much easier in polar. So convert this into a polar. So this will be equal to 264.7 minus 87.73. Now, when we divide the magnitude. So it's 100 over 264.7. This is 0.378. And for the angle, we subtract 0 minus 87.73. 0 minus 87.73, and this equals to 0.378 angle of plus 87.73. That is basically your current. Now I want to find VC. This is your IS, this is your reactance. So VC, Ohm's law, the current times the impedance. So it is 0.378 angle of 87.73 times minus J 265.3. Convert this to polar, so 0.378 angle of 87.73. This one, the magnitude is 265.3 and the angle is minus 90. So minus J is minus 90 plus J is plus 90. Multiply the magnitude with the magnitude. So this will give you 100.28 and add the angle. So in the division we subtract, in addition we basically add the angle. So this is minus 2.27. So we calculated IS and VC, but in what? This is done in phasors. Now I need to find IS of t. IS of t, you take the magnitude 0.378. Since my function is sine, so this would be a sine of 2 pi times 60 t, and then you add the angle plus 87.73. And your VC of T, take the magnitude 100.28, the same sign, the same 2 pi times 60T frequency, and then the angle is minus 2.27. So that is the first part, how to find IS of t and VC of t. The second is basically we want to find the phasor diagram. Now in the phasor diagram, we draw vectors. Let's start from VS, our reference. It's basically a vector with an angle of 0. Remember, this was basically your VS. Let me write them in the polar format. So now, to draw the phasors, you have to draw them in the polar format. So VS was 100, angle of 0. Your IS is basically equal to 0.378, angle of 87.73, and your VC is equal to 100.28, angle of minus 2.27. Now to draw this, VS is a vector, magnitude 100. So this is basically your coordinate. Now let me change the color. This is your VS. Your VS is a vector. This is your VS. Magnitude is 100. Okay, and the angle is 0. Then we need to find IS. Your IS basically is a vector with a small magnitude. Now this is 90. So this will be less than 90, little bit, and small. So this is something like this. Angle of 87.73, and the magnitude is 0.378. This is the vector. Finally, we want to find basically our VC. Okay, so this is VS, this is my IS, and here this is a vector with an angle minus, so it will be something like this. This is angle of minus 2.27, magnitude 100.28, and this is basically your VC. So that is the phasor diagram of VS, IS, and VC, and this is how you approach an AC question. There is one idea that is repeated, as I mentioned earlier, that what if I have two supplies and one of them is sine, one of them is cosine? I'm planning to answer such a question in shortly. Thank you and bye.